Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's class is voltage division and current division from Unit 2 Network Theorems of Electric Circuit Analysis. On completion, the students will be able to differentiate between voltage and current divider rules and also apply voltage division on series and current division on parallel circuits. Current division rule. A parallel circuit acts as a current divider as it divides the total circuit current in all of its branches. The following diagram shows a current divider circuit in which the total current I has been divided into currents I1 and I2 into two parallel branches of that circuit which are having resistances R1 and R2 respectively. Here the voltage drop across both the resistances is the same value, that is V. According to Ohm's law, I1 can be given as V by R1 and I2 can be given as V by R2. Let R1 is the equivalent resistance of the circuit and it is given by R is equal to R1 R2 divided by R1 plus R2, where R1 and R2 are parallelly connected in the circuit. And from the circuit we shall write I is equal to V by R, and substituting the value of R as R1 R2 by R1 plus R2 in the above equation, I equal to V by R, we are getting I is equal to V into R1 plus R2 by R1 R2. As the voltage across both the resistors is the same, we shall write V is equal to IR1 which is also equal to, V is equal to I1 R1 which is also equal to I2 R2. From equations 2 and 3 we get I is equal to I1 R1 into R1 plus R2 by R1 R2, that is equal to I1 into R1 plus R2 by R2, cancelling R1 on numerator and denominator. Therefore, we shall write I1 is equal to I times R2 divided by R1 plus R2 from the previous result. Similarly, we can write I is equal to I2 into R2 into R1 plus R2 by R1 R2, which can also be written as I2 into R1 plus R2 by R1. And cross multiplying, we can get I2 is equal to I times R1 divided by R1 plus R2. The above two results in equations 4 and 5 give the expressions for current division rule. From these equations, we may state that the current in any of the parallel branches is equal to the ratio of the opposite branch resistance to the sum of all resistances multiplied by the total circuit current. Voltage division rule. A series circuit acts as a voltage divider as it divides the total supply voltage into different voltages across the circuit elements. So in current division rule, current is being divided, whereas in voltage division rule, the supply voltage is divided across the circuit elements. The following diagram shows a voltage divider circuit in which the total supply voltage V has been divided into voltages V1 and V2 across the two resistances R1 and R2. The current through both the resistances are the same, that is I. According to Ohm's law, we shall write V1 is equal to I into R1 and V2 is equal to I into R2. Let R be the total resistance of the circuit and it is given as R is equal to R1 plus R2. Also from the circuit we shall, substituting that, we get V is equal to I into R which is equal to I into R1 plus R2. Since I is equal to V1 by R1 and also equal to V2 by R2. From the equations 2 and 3 we get V is equal to V1 by R1 into R1 plus R2, and we can write V1 from the above equation as V into R1 divided by R1 plus R2. Similarly, we shall write V is equal to V2 by R2 into R1 plus R2, and from this we shall cross multiply and write V2 is equal to V into R2 divided by R1 plus R2. Hence, the above two equations are the equations of voltage division rule. It may be said that the voltage across a resistance in a series circuit is equal to the product of the value of that resistor and the total supply voltage divided by the total resistance of the series resistors. Quiz questions on voltage and current division. Define current division rule. Define voltage division rule. Thank you.